Okay, so this is part two of the regression history and purpose. And so I'm going to start off with a fairly simple example. I've already run it here. And as you can see, this is Emacs running both the R code, which is on the top, and then down here is where the output's going to show. So before, what I did is I just talked to you a little bit about the history and the people involved in developing regression, and that's the first 4 lines, and those are just comment lines. But what I want to do is I want to go through regression as a simple operation. So what I'm doing is I'm submitting each one of these lines, and I want to show you what they are. So I just submitted these first 2 lines that are here that were highlighted before, and I'll just highlight both of them. So I've created 2 objects, x and y, and I've assigned them 5 different values. So I have x and I have y, and those 2 vectors I can plot, which I've done already, and let's see if I can pull that up easily. Okay, so I have x is 1, y is 4, x is 2, y is 8, and so each one of these data points represents these pairs of values that are represented in these 2 vectors, and I just plotted them. And then what I want to do is I want to run a regression, and we run a regression using this function LM, which stands for linear model. And then the next thing I would like to do is look at the regression results graphically, and I can show you that. And these are the graphic results where we have both we have the line of best fit along with the observed values, and this line of best fit has an intercept and a slope, which in order for me to really show you, I have to change this because I want to include 0 in here, and I think let's include that, and we can go back here. So now we have a true 0, and then what I want to do is I'm going to execute this again, and we'll go back to the plot so that you can see that when x equals 0, y equals some value, and it's going to be 5 point something. And then for every increment in x, y will increase. So what we want to do is find out what those results are. And the results are here, as I said. This is the intercept. The intercept is 5.3, and for every incremental increase, so unit increase in x, y increases by 0.7. So this is our intercept, our y-intercept, often referred to as A or y naught. And then this is B. This is the slope for the line of best fit. And so what we would see is, based upon this summary, we have y as a function of x, so it would be y is equal to 0.7 times x plus 5.3, which is the same as y equals here bx plus a, which is also equal to bx plus y0. So what we've done here is we've run a regression. I created some bogus data. I plotted it. It's a bivariate plot because I only have 2 variables. I created this regression, and then this AB line just overlays the line of best fit onto the graph. And then I showed you the summary so that I could take out the line of best fit components so that you can see that y is really a function of x, and it's a function of x by multiplying x by 0.7 and then adding 5.3 gives us our best guess or our prediction of y given an x variable. And that goes back to the purpose of regression. The purpose of regression is to predict values of y given x or multiple x's. And that's what this class is going to be dealing with. Okay, from this point forward, I'm going to go into a little bit more detail about B and A and how they're computed, so stay tuned for the next video.